Okay, so we're going to look at the same ester, methyl propanoate, but this time we're going to use an alkali for the catalyst. So it's alkaline conditions. So if we choose a strong alkali like sodium hydroxide, it's important to put the AQ because hydrolysis, it's going to be the breaking of the bond due to the action of the water. So we get our water from our solution here. So the bond that's being broken is the bond that was made. Okay, so if we do an equation plus H2O, and that's from our solution, then we're going to break that bond. So we've got our two fragments there. Okay, so we're putting the water back, so we'll put the H there and the OH here. Okay, don't worry about bond angles and such like, I've just done that so that it fits, so I'll put a plus sign there. Alright, so that H2O, we've put the H on and the OH. So really at that point it's like the acid catalysed hydrolysis, only that's not the end of the story, because if you think about it now, we've got our carboxylic acid in the presence of a strong alkali. So these two are going to react as a neutralization reaction. Okay, so effectively now we've got a second step. So if I write out here the carboxylic acid, so that's what we've just made. So really, if that's in the pot in the presence of the strong alkali, then there's no way they're going to resist reacting with each other. So they're going to react. So think now back to your acid reactions. You've got an acid with an alkali. That's going to make a salt. So definition of your salt, remember, is where the H plus from the acid is replaced with the positive metal ion, and in this case it's going to be our sodium. So the hydrogen ion has been released, and it's sodium that takes its place. So really important how you write this. The bond between the oxygen and the sodium is an ionic bond. You've got a metal and a non-metal, so don't go drawing a stick in between them, because it's not a covalent bond. It's okay to write it like that. Sometimes you'll see it written like that. That's equally fine, provided you put the charge on both of them, that's okay. Okay, so your sodium ion has taken the place of the hydrogen ion. The hydrogen ion then will react with the hydroxide ion to make your water. So I'll just cross through that just so that doesn't confuse us. So there you go, that's kind of the second step there. So when you look at these two reactions now, hang on a sec, you've actually got two steps. We can actually add them together to give us our overall. So if we look at everything on the left and everything on the right, so you should be able to spot a few things that we can cancel out here. So if we see, we've got the carboxylic acid that was made in step 1 gets used up in step 2. That's our intermediate, if you will, that can get cancelled. The other thing that we can cancel here is our water. Okay, gets used up in step 1 and regenerated in step 2. So when you add these two together, what you end up with then for your reaction equation is the ester reacting with the sodium hydroxide. Okay, so plus the NaOH, so this one plus this one, and your products then, we've got our alcohol, and you've got the salt of the carboxylic acid. So in this case, it's the sodium propanoate. So in the exam, if they're asking you for the balanced equation, this is the one that they want. So in the exam, check what the catalyst is. If it's an acid catalyst, it's just this. If it's the alkali catalyst, we know that this happens, so it ends up with this. So an alkali catalyzed hydrolysis will give you the alcohol and the salt of the carboxylic acid.